In this lab, we will be finding the specific heat of copper metal, which looks like this. We're going to use copper shot, is what it's called. First thing we're going to do is take the mass of this copper. So we'll put it on our scale, hit tare, put our copper carefully into here. And record its mass. Next, we will take our copper shot and we will put it into this large test tube. And what we're going to do is we're going to heat this copper in a bath. And eventually, we'll take the hot copper and pour it into some water to find its specific heat. So we'll leave this here for about 10 minutes, come back to it, and move on from there. Now that we have heated our metal for several minutes on our hot plate, we're going to take the initial temperature of the metal, and we already know the initial mass. We're going to take the initial temperature of the water and its volume, which will tell us its mass, and then we will put them together into the styrofoam cup and measure their final temperatures. We'll start with the temperature of the hot water bath. We'll take our temperature probe, put it into our hot water bath, continue to stir it. When you take the temperature in a hot beaker, you don't want to touch the actual sides of the beaker. You want to simply touch the liquid that you are measuring the temperature of. Of course, we do expect this to be close to 100 since it's boiling water, but it won't be exactly necessarily. That's due to the atmospheric pressure, perhaps some impurities in the water. So it's going to be close to 100. And you can see here on our LabQuest, it's leveling off at this temperature. So you can consider this as the starting temperature of the metal. Okay, so we're measuring the bath temperature, but that tells us the metal's temperature as long as it's been in there for a while, which it has been. Okay, next we're going to take the volume of the water in the graduated cylinder. With the dark background, you can now measure the volume of water in the graduated cylinder. Next, we'll take our water from our graduated cylinder, pour it into our calorimeter, which is our styrofoam cup, and then we will take its initial temperature in here. Again, we continue to stir it. You can see the temperature is going to be a lot lower than the boiling water, of course. It's going to be pretty close to room temperature since it's been sitting in the room. Once we get a stable reading, we'll record that temperature in our data table for the initial temperature of the water itself. Okay, so here's the temperature that you can use for that. Our last step is to take our hot metal, use a glove for this, pour it into our styrofoam cup, which has the water in it. Once we're done with that, turn this off, and we will stir this mixture until we get a constant reading. Of course, you can see that the water temperature is going to go up, and the metal's temperature is going to go down, and eventually they will meet somewhere in between. I'll wait for this to level off, which it looks like it is leveling off right now. We wanted to read the maximum temperature that we got because the water went up and then it went down. So it's already started to go down, so you want to take that highest temperature that you saw before.